Okay, good evening. Welcome to week 13 of this course. Today we will be looking at two important topics. Number one will be the contingency analysis. And number two, we will be looking at analysis called multiple regression analysis, which will be also very important for your project. So this analysis called contingency analysis is when you have two variables which are categorical, which is also in one of your assignment question. So we will only look at one learning outcome for this analysis called chi-square, although there are another one more, which is goodness of it, I actually removed them. We will just focus on this one called contingency analysis. So the learning outcome for this topic is you will learn how to set up a contingency analysis table and how to perform a chi-square test of independence. This is what you will learn in this chapter. This is especially useful when you have independent variable which is categorical and also the dependent variable which is categorical. Okay, so why there is a need to know this analysis is not all the time you will get data which are continuous. Sometimes you will get data which is nominal or ordinal. For example, a bank may want to use a code to indicate whether the customer is good or poor credit risk. Two levels on here, good or poor. And then they want to see whether the person will buy or rent a house. Okay, so we have good and poor credit risk. Then we have buying or renting a home. So why they want to know this is they want to see the credit risk status of the house owner. Okay, so this, when we do this, we call them as a 2x2 table. Both credit risk and home ownership are qualitative. What is meant by qualitative is categorical or nominal. And some of the chapters we covered so far from chapter 8 to chapter 12, they are actually used for variables which are continuous. So this chapter, which is related to contingency analysis, will cover that kind of analysis. This is useful analysis which is done in areas like marketing, where you look at whether like a salesman, he wants to find out whether the next sales target will buy or don't buy. That depending on the gender of the sales target. So gender against buy, don't buy, that kind of analysis, we will do a contingency table. So when we do contingency table, we are actually testing multiple population proportion. As you already learned this in your one sample, two sample test. One sample test, you have your population proportion equals to 0.5 or 0.4. Two population proportion is when you look at P1 equals to P2. P1 is greater than or smaller than P2, right? That's two sample population. Now we are looking at multiple population. So you will have at least proportion 1, proportion 2, and proportion 3. 3 and above. Then we call them contingency table. So for contingency table, we will have at least a 2x2. 2x2 table or any number greater than 2x2. Okay, 2x2 will give you 4 proportion. 2x3 will give you 6 proportion. 3x3 will give you 9 proportion. Okay, and these variables are all categorical. Okay, and after you collect your data, you classify your sample observation into 2 or 3 more groups. Then only we want to test this analysis. And chi-square test is used to determine whether these two variables of interest are independent or dependent. Okay, independent or dependent. So this is an analysis called test of independence. So let's look at this example of a source of funding and gender. So gender, we have two categories, male and female. source of funding, we have two categories, private funding or state funding. Okay, so here we have a 2x2 cross-tabulation table or contingency table. The last row and last column is actually the totals. So we want to know whether the source of funding is dependent or independent of gender. Okay, dependent or independent of gender. So the null hypothesis states that gender of yearbook editor is independent of the college's funding source, and the alternate is gender of yearbook editor is not independent of the college funding source. Okay, the alternative you can also say dependent. Okay, this is independent. The alternate can be dependent. Okay, so that is the null and the alternate hypothesis in a contingency table analysis. Contingency table analysis. Okay, to do this chi-square test, the formula looks a bit messy like this. Chi-square equals to the summation of I equals to 1 to R. R means the number of rows. J equals to 1 to the J column. So how many rows you have, how many columns you have. Okay. Then we will take the OIJ minus EIJ squared divided by EIJ. Okay, what is meant by OIJ is the observed frequency, and this EIJ is called expected frequency. Yeah. Okay, how do you get this expected frequency? Is this OJ is actually the data you collected. This EIJ will be calculated based on this formula. The row total times the column total divided by the grand total. Okay, row total times the column total times the total sample or your grand total. So if you look at the same example, we were looking at gender, male and female. We want to see whether they are the source of funding, whether it's from private or state, is it independent or dependent of the gender. This number called 14, 43, 141, and 23, these are called observed frequency. Okay. What is meant by 14 here is we have 14 male editors who are funded by private funding. We have 141 female editors who have private funding. We have 43 male editors who have state funding and 23 female editors who have state funding. So that is how the table will be derived. So the first task is we already have the OJ, right? Observed frequency is 14. We want to calculate what is the expected frequency for this cell. So to get the expected frequency for this cell, you will take the row total, the column total times the row total divided by the grand total. So 155 times 57 divided by 21, yeah, you get 39.98. So the first cell, for this first cell, the expected frequency is 39.98, okay? The second cell is cell number 21, okay? Number 21, number 2 is here, okay? Yeah, and when we take this number, okay, we take for this cell, we need to take 155 times 164 divided by 221. We get 115.02 as expected frequency for this cell. And then we have the cell here, 43, right? We will take the 57 times 155, 57 times 66 divided by 221. For this cell, we will take 164 times 66 divided by 221. So once we get these four expected value, then only we can run the analysis, because the analysis will be observed frequency minus expected frequency divided by expected frequency. Yeah, okay. So we can actually set up a table like this. So we already know the observed frequency for observe 1 is 14, observe 2 is 141, observe 1 2 is 43, observe 2 is 23. Yeah, And we also calculated the EIJ, which is 39.98, 17.02, 115.02, and 48.98. So the next task will be to take this value minus this value, then square the value. Finally, you need to divide the value by EIJ. That's the task you need to do. So when we do this task, we have four values, right? Okay. So 14 minus OIJ minus EIJ divided by EIJ. You have four cells. So you have 1, 2, 3, 4. Later I can also show you how you can do them in a column format. So after you calculated these four, you sum them up. Okay. You sum them up. You will get a value of 76.19. This is called the chi-square value. So in chi-square value, similar to your t-test and z-test, you also need to look at distribution. For chi-square distribution, the chi-square distribution will look like this. Okay, will look like this. I've already shared with you the chi-square distribution table. You can look at them. This is the formula for calculating chi-square. We already get 76.19. So we need the chart, right? Okay. Before you can look at the chi-square distribution, chi-square distribution has a degree of freedom, which is equals to row minus 1 times column minus 1. Okay. So your row is 2, 2 minus 1, 2 minus 1. So you get a degree of freedom 1. Then only we can look at the table to get this critical region value. Okay, critical region value. Okay, so how do you get that number? Is you can look at your chi-square distribution table. Let me show you. Yeah, chi-square distribution table. Okay, you get areas in the right tail. Let's say you want a 0.05. Here we want alpha value of 0.05. Degrees of freedom is 1, right? Okay, how do you get your chi-square value? Is by looking at this table, 0.05 degrees of freedom 1. Okay, 1 degree of freedom, your alpha is 5%. You get a critical value of 3.841. Okay, 3.841. So what we will do is now we will draw the chart. Okay, this is your critical value. 3.8415. Anything smaller than this number, you accept the null. Anything greater than this number, you reject the null. Okay, so our null and alternative is here. Null says the two variables, which is gender and source of funding, is independent. The alternate says it is not independent. Okay, so here we get a calculated value of 76.19, which is in this region. This is the rejection region. So we will reject the null and conclude that the alternate is true. And the conclusion will be yearbook editor gender and yearbook funding source are not independent. Or you can say it is dependent. Okay? Or you can say it's dependent. So this is how you can test a 2x2 contingency table using this test called the chi-square test. Okay. So I will show you another example with a 4x3 contingency table. We have marital status, which is single, married, divorced, and widowed. Here we have the absentee rate, 0 days, 1 to 5 days, and over 5 days. These are the three absentee rates. For 0 days of absenteeism, we have 200. For 1 to 5 days of absenteeism, we have 200. For over 5 days, we have 100. Okay. For single, married, divorced, and widowed, we have 200 of them who are single, 150 of them married, 100 divorced, and 50 widowed. Okay. This is the distribution for marital status. And this is the distribution for your absentee rate. No? So what we want to know is the absenteeism rate dependent or independent of marital status. Okay, that is what we are trying to do in this test. Huh? So first we need to write the null and the alternate hypothesis. The null hypothesis says marital status and absentee rate are independent. And the alternate says the marital status and absentee rate are not independent. Or we can also say dependent. No? Okay. Independent, dependent. Okay. Independent, dependent. No? Alpha is 5%. And we need to calculate the chi-square degrees of freedom. Degrees of freedom, we have 4 rows and 3 columns. Okay, 4 rows and 3 columns. So 4 minus 1. Okay, 4 minus 1 is 3. 3 minus 1 is 2. 3 times 2 is 6. Okay, 6. Huh? So degrees of freedom is 6. Alpha is 5%. Your critical value will be degrees of freedom 6, alpha 5%. This is your critical value. 12.592. 12.592 is your critical value. So now what we need to do is first, we need to calculate the EIJ. EIJ is the expected value. Expected value. So the expected value for the first cell, for this cell, right, is 200 times 200 divided by 500. Okay, so you get 80. Yeah. For the second column, it is 200 times 200 divided by 500. So you get the same number. But for the third column, you have 100 times 200 divided by 500. You get 40. So that is how EIJ of each cell you need to calculate before we can do this. Before we can do this. Okay, after you have done this, this is your OIJ, which is your observed frequency. This is the expected frequency. We can also put them in a table form. FO is observed frequency. FE is expected frequency. So they are coming from this table. Okay, I hope you know how to copy and paste in a changing them in from row to column. So what I did was I copied and put them in row format. So we already have the frequency of the observed and expected. So we will first take the observed minus the expected. We get this value. This number minus this number, we will get the residual. Next, we will square them. We will square them. Finally, this squared value will be divided by FE, which is this one. Which is this one. So 16 divided by 18, you get this. 4 divided by 80, you get this. 36 divided by 40, you get this. Okay, so that is how this FE is calculated. So after we have calculated all the 12 values, we will total them up, which is called summation. The summation gives you a chi-square value of 10.883. 10.883. So once we get this value 10.883, this is what we call as the calculated chi-square value. And the critical value for the chi-square test, 4 minus 1 and 3 minus 1, you get degrees of freedom 6. Alpha value 5%, we already get from this table, right? 12.592. So we write the number here, 12.592. We want to know this number that we calculated is on the left-hand side or right-hand side. Smaller than or larger than. Okay, smaller than or larger than. And you can see that a 10.888 is smaller than 12.596 is this region. So because 10.88 is less than 12.5916, we do not reject the null hypothesis. Thus, we will conclude that absentee rate and marital status may be independent. Okay, may be independent. Okay, yeah. Any questions on how to calculate the FO, FE, and find the critical value? Okay. Any questions on the critical value? Oh, okay. Okay. So now we will look at this one exercise, which is a very simple exercise. We now have a 2 by 2 table. We have the funding, public funding or private funding. We want to see whether they invest in an aggressive portfolio or a balanced portfolio. Okay. And the total number is 320 public sector employees and 380 private sector employees. So the total number is 700. 700. So what we want to know is whether this investing preference and the sector. Investing preference is aggressive versus balance, and the sector is public versus private. Are these two variables independent or not independent? Okay. So part A is you need to write the hypothesis first and then calculate. So we will do only number A. Just look at number A. Can you write your null hypothesis and the alternate hypothesis, and then calculate the expected frequency? Okay, expected frequency. And then I will show you the steps. You have to try this out. In the exam, you cannot just follow, right? You need to still do them. You can try putting them in a table form. Take out a piece of paper and a pen, and then start writing. For those who will be doing face-to-face, you better start doing it now. Put them into 4 rows. Okay, write down the numbers, and then calculate your expected value. Okay, so this is what you need to do first. Can you do that quickly? After you have done this table, then only we can calculate the expected frequency for these 4 values, right? So now this observed frequency is 164. The expected frequency will be 400 times 320 divided by 700. Okay, for this cell. 400 times 320 divided by 700 for this cell. 300 times 320 divided by 700 for this cell. 400 times 380 divided by 700 for this cell. And 300 times 380 divided by 700 will be the expected value for this cell. Okay, so this is what I have done. After you do the calculation, you can try it out. Use your calculator. Hopefully your calculator works. 400 times 320 divided by 700, you should get 182.857. 300 times 320 divided by 700, you will get 137.143. 400 times 380 divided by 700, you get 217.143. And then 300 times 380 divided by 700, you get 162.857. Okay, 0.857. So those are the numbers that you get for FE. These numbers are actually FO. 1, 2, 3, 4, they actually FO. Okay. Observed value. We already calculated the expected value. Now we need to take the differences first, right? Okay. Can you write them down? Okay, and then do some calculation together. Write down the FO and FE side by side. before we can start the calculation. Huh? We want to develop a table like this. Huh? So we need the FO, we need the FE, we need the FO minus FE, we need FO minus FE squared, and then FO minus FE squared divided by FE. Then only we can total them out at the bottom. So we need to have these columns. 1, 2, 3, 4, 5 column with 4 rows. Okay, can you do that? Five columns and 4 rows. Then only we can start the calculation. Degrees of freedom is 2 minus 1 and 2 minus 1. So that is 1 degree of freedom. And 1 degree of freedom at 1 degree of freedom, 1%, right? The cutoff value 6.635. So we need to draw this first, this table, okay, before we do the calculation. Okay, so these are the 4 numbers. FO, you have the 4 numbers, FE, the 4 numbers, and then we take FO minus FE, we get the difference. We take, this column is taking this column squared, right? Okay, this column is taking this column squared of these values. And then here is FO minus FE, which is squared, right? This one. FO minus FE squared is this column. This column divided by this column, you will get this. This column divided by this column, you will get this. This column divided by this column, you get this number. And finally, this column divided by this column, you will get this. Now, when we total up, we will get a chi-square. Summation of this formula, chi-square equals to 8.358. Okay, 8.358. So this 8.358, it is smaller than the critical value or larger than the critical value is what we decide next. So the critical value we already got from here, 6.635. 1%, 1 degree of freedom. 2 minus 1, 2 minus 1. 2 minus 1 times 2 minus 1, you get degrees of freedom 1. 1% alpha, the critical value 6.635. So we will put the 6.635 here. This number here, this is the cut-off value, critical region. And the calculated value 8.358 is actually greater than 6.635. Okay. Since 8.538 is greater than 6.635, we can reject the null hypothesis and conclude that investing preference is not independent of employment sector. Okay. Employment sector was private and public. This is what we are trying to do, right? Again, public and private. And then we have aggressive and balanced fund. So null says they are independent. Alternate says they are not independent. Okay, so now we rejected the null. So the alternate is the correct one, which is saying investing preference is dependent of employment sector or not independent. Same. Okay. Any questions on how to do the calculation and how to accept and reject the hypothesis using this chi-square table? Yes, any questions? Nope. Okay. Since there's no questions, we will move on to the last analysis called multiple regression analysis. Okay, so we have covered most of the analysis, and now the final analysis that we will cover is this called multiple regression analysis. So in this chapter, we will cover the simple linear regression and also multiple linear regression. And in multiple linear regression, we will also look at how we can incorporate dummy variables in the regression. So those are the things we will be looking at in this topic. So there are 7 learning outcomes for this chapter. This is a very important chapter. Hopefully you pay a bit more attention. For your friends who are not here, please send my regards to them. Final exam, you will have a question on this. So God bless you. We have 7 learning outcomes for this chapter. Outcome number 1 is we will try to understand the general concepts behind model building using multiple regression analysis. And this particular analysis is the most powerful analysis available in the first generation analysis. And this will become the building block for any kinds of analysis you plan to do after this. If you are planning to do machine learning, you are planning to do big data analytics, they are still dependent on this understanding called multiple regression analysis. So for God's sake, please pay attention to the discussion. Hopefully this will carry you through for the rest of your life. Okay, at least you understand better what is being done. That's number 1. Number 2, we will apply multiple regression analysis in decision-making situations. So you will see how multiple regression can be applied in decision-making. Let's say you want to buy a certain stock, or whether you want to invest in a new plant. That all can be done using this analysis called multiple regression analysis. And then we will analyze computer output. So for final exam, you will be given computer output and you need to interpret the regression results. Okay, you don't have to do the calculation. If you want to do a multiple regression calculation, maybe you'll take 2 hours manually. So you will be given a computer output. Usually we will use computer output from SPSS, and then you have to interpret them. Outcome number 4, we will understand how to test a hypothesis of a multiple regression model, overall model. Whether we have an overall model or not, we will run some tests, and then we will also test in individual variable in your model. Let's say you have 3 independent variables. Whether all 3 independent variables are significant or not, we will do the test also. The first one, which is the multiple regression model, we will do an F-test. For the individual variable in the model, we will do a t-test. Outcome number 5 is when we run multiple regression, there will be certain problems that you will face. For example, we have a problem called multicollinearity. We have a problem called dummy variables. We have a problem called constant variance. These are some things you need to understand and how to remedy them. Okay, how to remedy them. Okay. Outcome number 6 is we will learn how to incorporate qualitative variables. What is meant by qualitative variables is a categorical variable. For example, we want to use gender in the regression, or we want to do marital status in the regression. We need to do dummy coding. Okay, dummy coding. And then finally, we will look at the assumptions in multiple regression. There are 7 assumptions that you need to test. Some of them are based on graphical inspection. Some of them have cut-off values. Okay, for example, VIF, it must be less than 5. But for constant variance is visual inspection. Those are some of the things we will learn in this topic called multiple regression. Why do we need to understand multiple regression? Okay, when we do analysis, sometimes we want to know what is the effect of variable of one independent variable on another dependent variable. For example, here we want to see the effect of stock price on the dividends issued. Stock price and dividend issues. We have one independent variable, one dependent variable, or we want to see the relationship between product sales and advertising. Okay, one independent, one dependent. Then we will do an analysis called simple linear regression. Okay, simple linear regression. One independent, one dependent. But most of the time we will be interested in more than one. Let's say we want to look at the price, market value of a home. Market value of a home. We can look at size and age of the property. So now we have size and age, which are two independent variables, and the dependent variable is the price, market price. Okay, market price. So this is where we will move away from simple linear regression, regressing one independent variable against the other dependent variable. We will run both the independent variables together. Then it becomes a multiple linear regression. Multiple linear regression. Okay. So here we have other situation where we can also look at what factors influence automobile sales. What factors influence automobile sales? So if you look at the literature and the theory, they will tell you that the price of the car, competitor sales and advertising, and also economic variables like disposable personal income, inflation rate, and unemployment rate. Here we have multiple predictors or multiple independent variables. Then your analysis will become an analysis called multiple linear regression. Okay, multiple linear regression. So these are some basic terms you need to understand in multiple, linear. When you talk about regression, these are some of the terms you need to understand. The first one is what we call as a model. When we say model, we can present the model graphically, or we can also present the model in terms of equation. So here we can see an example. Let me show you quickly. Like this. So we want to look at the sales price. Sales price is dependent on sales, how much you get sales, right? Pie sales, okay? Your pie sales, which is the total pie sales. How much do you get in a week? Pie sales is dependent on the price and advertising, okay? So when you write an equation, you write B0, which is your intercept, plus B1, which is your coefficient, and then the independent variable 1. B2 is the coefficient of independent variable number 2. You can write them in equation form. You can also draw them like this. Price and advertising influencer sales. Okay, so this is the first independent variable. This is the second independent variable. That's why we can actually draw them using equation, or even using drawing, or using equation. That's what is meant. So in model specification, we need to determine which are the independent variables, which are the dependent variables, and get the data to measure the independent and dependent variable. That's what we meant by model specification. So model building and model diagnostic, they are interrelated. Model building is you need to determine which will be the independent variable, which will be the dependent variable. For regression analysis, unfortunately, currently we can only model one dependent variable at a time. Okay, one dependent variable at a time. So one dependent variable, multiple independent variable, we call them multiple regression. One independent variable, one dependent variable. It is called simple linear regression. Okay, simple linear regression. This term called model diagnosis is where we will assess how good is our prediction. Later we will talk about values like R square. We will talk about errors. These are all related to what we call as the model diagnosis. Okay. So step number 1 in your model identification is indicate the dependent variable. Okay, indicate the dependent variable, which I have in your project will be your one of the dependent variable will be satisfaction. Another dependent variable will be actual use, right? Okay, intention to use. They can be your dependent variable. And then you identify, list the potential independent variables. You have 3 independent variables from the lab, right? To your satisfaction, then satisfaction to your dependent variable, another dependent variable, you have only 1. So 3 independent variable, 1 dependent variable, 1 dependent variable, 1 independent variable, and another dependent variable. 2 regression, right? And then gather the sample. You don't have to gather the sample because data was already given to you. Huh? Okay. And then we will run this analysis using a software like SPSS. Huh? Okay. Because if you want to do it manually, it will take 2 to 3 hours to calculate all the coefficient. So what we do is we will run them using a software. Okay, so we will later I will also show you how to assess assumptions. So when you write equation for a simple linear regression, yi equals to b0 plus b1 x1 plus error. This error term is minimized when we do the least squares. So the equation is you have a constant, you have independent variable one independent, one dependent. This is a simple linear regression analysis. When you have multiple linear regression analysis, you still have one dependent variable, but you have multiple independent variables. So beta 0 plus beta 1 x1 plus beta 2 x2 plus beta k xk. So the number of independent variables must be at least 2 or more than 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. They are all multiple regression. One independent, one dependent, simple regression. Okay, that's a term used in the literature. So when we do regression, there are 2 reasons why you do regression. Number 1 is to do prediction. Okay? Prediction. This is usually the case for secondary or primary secondary data, which is collected for primary or secondary data, but they are objective data, actual sales, actual price. Okay, those kind of variable we can do prediction. But primary data which are subjective, satisfaction, intention, loyalty, this kind of variables, they are actually subjective. When they are subjective, then we need to focus on the explanation. If your independent variable increases, what happened to your dependent variable? That is what we call as explanation. Whereas prediction is if independent variable increases by 1 unit, what happens to your dependent variable? That is what we call as the prediction. How many units will increase? Okay, so now we will look at an example of a multiple regression analysis. In this multiple regression analysis, we have one dependent variable, which is the pi sales. The pi sales is in units per week. The independent variable, we have 2 of them. One is price. The other one is advertising. Price is in dollar. Advertising is in hundreds. Okay, hundreds of dollars. And this data was collected over 15 weeks. Okay, 15 weeks. And this is the data. Week number 1 until week number 15. These are the week. This is not a variable in the model, right? This is number of weeks only. The first variable you have in the model is your dependent variable, which is the pi sales. Pi sales, these are the sales for 15 weeks. This is the price of the pie for 15 weeks. This is the amount of advertising in hundreds for the 15 weeks. So when you write 3.3, it is actually 3.3 times 100. Okay, so you move 2 more places, 330. This value is actually 330, but we put 3.3 because it is already in hundreds. Okay, that's how you understand your data. So we have 1 dependent variable, 2 independent variables. Okay, so when you want to write an equation for multiple regression, we have the sales which is your pi sales, equals to beta 0 is your intercept, plus beta 1 price is the first variable, right? Beta 1 is the slope of the coefficient for price. Beta 2 is the slope of coefficient for advertising. So this beta 0 plus beta 1 x1 plus beta 2 x2 can also be represented by a research model which look like this. This is graphical, this is equation. Okay, graphical and equation. So we have an independent variable called price. We have independent variable number 2 called advertising, and the dependent variable is the pi sales. So it is actually the same equation or the research model, the drawing. So after you have collected this data, what you will now do is you can create your research model. Okay? In doing this research model, we will run them using the software called SPSS. So in SPSS, what they will do is they will create for you the correlation coefficient. What is a correlation coefficient is the strength of relationship between your independent variable 1 and the dependent variable, independent variable 2 and the dependent variable, and also the independent variable 1 and independent variable 2. That is called the matrix of correlation. The formula looks very messy, but you don't have to worry because the software will be able to do that for you. Correlation. And then what we will do is we need to test whether these correlations are significant or not. This is the null hypothesis and the alternate hypothesis. Null says the correlation is equal to 0. 0 means no correlation. The alternate says the correlation is not equal to 0. So it can be positive or negative. So this is how we were doing hypothesis testing. 5% two-tail, right? 5% two-tail. The test is the t-test. But when you run them in regression, the table will be given like this. The correlation between pi sales and price is negative 0.443, and that's a 1 star here, right? 1 star means it is significant at a 5% level. 2 star means it's significant at the 1% level. So that's how the 1 star, 2 star indicates. 2 star means it's stronger correlation. A stronger correlation. So this is how we look at the correlation. And correlation can be negative, can also be positive. Negative means when the independent one of the variable goes up, the other variable goes down. Okay, they are in the inverse direction. Then you call them negative relationship. If both variables move in the same direction, we call them positive relationship. So how do you know they're positive or negative? The literature and the theory should be able to tell you. Literature and the theory should be able to tell you. Okay? So that is why we interact with the literature. So this is a test called the correlation. And correlation is a bivariate analysis. You don't test hypothesis using bivariate analysis. We will use multivariate. So when we run the multiple regression in the software, what we are trying to do is we want to identify the intercept, okay, which is the y-intercept. We want to know what is the coefficient of or slope of the variable, independent variable 1, slope of the independent variable 2, and slope of the independent variable k. So if the slope is positive, means the independent variable and the dependent variable, they move in the same direction. If the slope is negative, then what you are saying is when independent variable increases, the dependent variable will go down. Okay, they are inverse. Okay, they are inverse. This random error usually we don't write because least square analysis will minimize this error. Okay, so we actually don't need to write the error. So this is the regression coefficient for two independent variables. So we have the dependent variable. This is the intercept when all variables are 0. When you don't have any value for the independent variable, what is the value for y is given by the intercept. and then you have a beta 1 times x1, and then beta 2 times x2. This is what we are trying to calculate, beta 1 and beta 2. Okay, beta 1 and beta 2. So after we have collected the data, we write this equation. We will use the SPSS to develop the model. And this is how the SPSS will run the analysis. Okay, your independent variable 1 and independent variable 2, they will try to develop an equation for you. So to run the analysis, under the analyze, the data set is already shared with you, called PySales. So you can try it out on your own if you want to. So we go under analyze regression. We will pick linear regression. Analyze regression, linear regression. Okay. And after you pick the linear regression, you will get a dialog box like this. They will ask you what is your dependent variable and what are your independent variables. And if you see the dependent variable is small, right? It can only accommodate one dependent variable at a time. So if you have A to B to C, you can only run A to B and then B to C. Okay. Hopefully you understand and get this into your minds. When you have 3 levels, you can only run from level 1 to the middle variable, and then the middle variable to the last variable. You need to run 2 regression minimum. We are not going to do this analysis called mediation. Just run 2 regression. Okay? 2 regression. So here we have the dependent variable, and then we have the 2 independent variable. We need to pick them. So here you may have lots of variables, but you want to model only 3 variables in the analysis. The dependent variable is PySales. The independent variable is price and advertising. Okay, that's how you set up the analysis the first time. Independent, dependent. Then we need to also have some options. These are called assumptions. Later I will also explain to them one at a time. Under the statistics, when you click the statistics, you need to click the confidence interval, and you have to change this to 90% because it is one tail. If it's one tail, it should be 90%. If it's 2 tail, then you can keep at 95%. We need to ask for descriptive. We need to ask for part and partial correlation. We need to ask for collinearity diagnostics. We need to ask for Darwin-Watson and case-wise diagnostic. And this case-wise diagnostic, later we will look at a term called outliers. Okay. So at the moment, these are the options you need to pick under the statistics. Okay, under the statistics. Next, after you have set this, you will click continue, and then you will go to plots. For plots, we need to check whether our standardized residuals follow a normal distribution. We will look at the histogram and normal probability plot. You need to tick this. And then we need to tick also this button called produce all partial plots. This will give us the scatter plot of independent variable 1 and independent variable 2, and the dependent variable. That is called the scatter plot. And finally, we also need to assess an assumption called constant variance or heteroescedasticity, homoescedasticity. So instead of that, the easier term to say is called constant variance. Constant variance. So we will pick the studentized residual and put it under the Y, and we will put the standardized predicted as the independent variable. Okay, independent variable. These are some of the things you need to click before you run the analysis. Okay, the options. Later I will explain what are the assumptions, the 7 assumptions you are testing. Doesn't matter it doesn't matter ODL or non-ODL. The answers are the expected answers are the same. Steps are the same. I've already shared you model answers, right? So you should be able to look at the model answers and how they answer. Huh? Okay. So this assumption you need to set up first, then only we can run the multiple regression analysis. Huh? Okay. So when you run the multiple regression analysis, you will get a long list of outputs. Huh? These are some of the outputs you will get. Huh? You can try it out with the data I've already shared with you. Huh? I've already given you this data called pi sales. You can follow if you want to. Huh? So when you run your model, the first table you will get is this table. Huh? This table will tell you what are your independent variable and what are your dependent variables. Right here, here you have your advertisement and price are your independent variable, and you have constant, right? Constant, advertisement, and price. Huh? And your dependent variable is pi sales. Okay, dependent variable is pi sales. Huh? So when we do multiple regression analysis, the first table that we will be looking at is this called ANOVA. Okay, ANOVA. Okay, do I have ANOVA? Okay, no. Why did I? Okay, this ANOVA table must be significant first, before we can look further. And the null hypothesis for the ANOVA is actually R square equals to 0 and R square not equals to 0. So this is what we are testing. If this is not significant, your conclusion is you don't have a model for regression. You don't have a model for regression. That's the first thing we need to do. This one. Once this is significant, then only we can proceed with interpretation of further tables, of the other further tables. So let's say you want to write an equation from the regression output. To write an equation from the regression output, we will look at this table called the coefficient table. Coefficient table. The coefficient table will give you the independent variable called price and the second independent variable called advertisement. The dependent variable is pi sales. So we can put sales equals to the first value, which is called a constant. We write 306.526. This is the number. And then minus 24.975, which is this one, right? This is actually the coefficient for price. Okay? Coefficient for price. Plus 74.131. This is the coefficient for advertisement. So this is how you can write an equation if the data is objective. Okay? If the data is subjective, usually we don't write an equation. We write hypothesis. Okay? So this is how you summarize them. Yeah. Any questions on how do you write an equation from the multiple regression output? Okay. Next, after you summarize the equation, how do you interpret the coefficient? This is your B1. This is your B2. Okay. So the interpretation is when price increases 1 unit or $1, your sales were reduced by 24.975 units. Okay, so this is the number, right? So it's actually 25 lah. Yeah. If your advertising increases by $1, you will get sales increase of 74. Okay, 74. And this advertising, we have already looked at it here, right? When you see here, the advertising is actually in hundreds, right? In hundreds. So if we say $1 increase is actually 100, 100. So this is how you interpret the B1 and B2. Okay. $1 increase in price, you get a reduction of sales by 25 units. A $100 advertising increase will give you 74 unit increase in sales, okay? Because the signs are negative and positive. Okay, signs are negative and positive. Huh? Okay, any questions on the interpretation of the coefficient? Huh? This is the unstandardized coefficient where you get from column number 1. Okay, column number 1. Huh? No? Any questions? Okay. Okay, next, if you are asked to predict sales during the week, okay, sales during the week, and you are given the value for the price, okay, 550 for the price, and for advertising is 350. What we can do is, if you see this equation, we will substitute price as the number given. We will substitute advertising with the number given. So here we already have the equation. Price we already know is 5.5, so we substitute with 5.5. Advertising is 350. Since 350, the advertising is already in hundreds. We will not put 350, but we will only put 3.5 because the data is collected based on hundreds, okay, based on hundreds. So when we calculate this, you get a value of 428.6216 pies, right? But you won't be selling this fraction pies. So you round it up to 429 pies. Okay, 429 pies. Yeah. Any questions on how to predict the sales when you are given with the independent variable 1 and independent variable 2 values? Okay, which you will also get during a final exam. Any questions on how to do this calculation? So you need to have this equation, substitute the values given in the question into the equation, and you have to calculate the value. And the value will follow the value of your dependent variable, right? This is unit, number of unit of number of pies sold, right? Okay, number of pies sold. Okay. No. Any questions? No. Okay. We have a value called the R square. Okay, the R square. The R square is measured by the sum of square regression divided by the total sum of squares regression. Where you get them in the output that you got, this is called sum of squares regression, 2,946 divided by total. Total sum of squares is here. So 29460 divided by 56493, you will get the R square. You will get the R square. And what we need to do is we need to convert the R square into percentage. When you convert them into percentage, your understanding or interpretation is 52% of the variance in price, in pie sales. Okay, 52% variance in pie sales can be explained by the two independent variables. Okay, the two independent variables. Total explanatory power is 100%. We have another 48% that cannot be explained is because we have other independent variable we did not include. Okay, for example, cost. Okay, cost of the product. Competitor pricing. Those are variables we did not include. Okay, location. Because if you are in urban area or rural area, that will also affect the total price sold, right? Okay, those variables we have not included. That is why we have another 48% of total variance that we cannot explain. Okay, so variance explained is 52%. Variance that cannot be explained, there is another 48%. Okay, 48%. So that is the interpretation of the R square. Every time you add a new variable to the model, R square will increase. Okay, but the problem is when you add more variable, your complexity increases. So the R square change will reduce. Okay, so that is why you don't see models with 20 independent variables. We will pick and choose the best independent variable so that we can explain the dependent variable well. That is why we go back to the literature review. Okay, literature review. So we have another term called adjusted R square. This adjusted R square is only important if you want to compare two different model setup. First model has 3 independent variables with 500 sample. The second regression, you have 10 independent variable and 1000 sample. Sample size is different, number of independent variables are different, then we cannot compare R square to R square. Yeah, R square is the same. R square small or big is the same. Go. How you write on it. We can also put R square like this, right? R square, or you write in word R square, they are also the same. Okay. Okay. Yeah. Okay. So this adjusted R square is only useful when you want to compare two different models. Other than that, the R square is already more than sufficient. Okay. And this R square depends on your area of study. Two things. R square depends on the number of predictors you have in a model. The more number of predictors you add to the model, the higher the R square. Let's say you have 10 independent variables, R square will be higher than 3 independent variables. Okay? And also the area of study. Let's say you're looking at area like HROB, 20% is already considered high. If we are looking at technology adoption, 50% considered high. And if we are looking at critical success factor studies, 75% is higher. So different areas, different model setup, more complex model versus more simpler models, R square will differ. Okay, R square will differ. So for your own project, you don't expect to get R squares which are 70%, 80%, because you don't have so many independent variables. Okay, especially when you have one independent variable, one dependent variable, 10%, 20% R square, that is already considered very high. Okay, very high. Okay. So in multiple regression analysis, we have two levels of analysis. The first level is to determine whether you have a valid multiple regression model. Okay, whether you have a valid multiple regression model is by looking at a test called the F test. Okay, the F test. So the F test hypothesis is written as this. Beta 1 equals to beta 2 equals to beta k equals to 0. This means none of your variables are significant, or none of your independent variables are linearly related to the dependent variable. Okay, no relationship. Okay, so I say no linear relation means no relationship between independent variable 1 and y, independent variable 2 and y, also no relationship. Your constant is also not significant. Then you will have the null. The alternate says at least one of the independent variables are significant. Then your F value will be significant. Okay, that is what we call as the test for the overall model. In some papers, they write the null hypothesis as the R square equals to 0. The alternate hypothesis is the R square not equals to 0. That is a test for the overall model. So the F test is taking mean sum of squares regression divided by mean sum of squares errors. And the degrees of freedom is given here. So when you take the F table, we will have 2 degrees of freedom. Degrees of freedom for the numerator is equal to the number of independent variables you have. And the degrees of freedom for the denominator is n minus k minus 1. Okay, n minus k minus 1. You need 2 degrees of freedom before we can look at an F table. Okay, before we look at an F table. So this is an example of how you can calculate manually, which you don't have to do. I'm just showing you here. Let's say we have the exercise we did was 15 cases, right? We collected data for 15 weeks. The number of predictors is 2, right? Number of predictors is 2. So your degrees of freedom is, degree of freedom 1 is k, right? K is equals to 2. Degrees of freedom 2 is n minus k minus 1, which is 15 minus 2 minus 1, you get 12. So what you need to do is you need to look at your F table. Degrees of freedom for the numerator is 2. Degrees of freedom for the denominator is 12. You will get a critical value for 5% as 3.885. Do I have the table here? I don't have. Later I can show you. 3.885, right? Okay, at 5%. And the F value calculated is 6.5386. So cutoff value is 3.8. The calculated value is greater than. So we will reject the null hypothesis and conclude we have a significant model. Then only we can proceed with the other tests. Okay. So this is what we call as test for the overall model. Test for the overall model. So like just now we already saw the output, right? In the output, we have a significant 0.012. This is actually the p-value calculated. This is the F value. This is the p-value calculated. Okay, this p-value 0.012 is less than alpha. Alpha is 5%. Okay, alpha is 5%. That is why we conclude we will reject the null, and then we conclude we have a model. Then only we can proceed further. Okay, so this is how the analysis is done. We have 2 independent variables. They will try to map them based on the correlation and get you the best equation, okay, by looking at the least squares method. In your output, they will also show you your standard error of estimate. Why this standard error of estimate is important is when you want to calculate your confidence interval, the bigger the standard error, the more further away you are from the mean. Not very precise, right? Okay, that is why we need to know the standard error. But most of the time, we are not going to calculate the confidence interval. So we need to interpret this based on your range. The highest value of your dependent variable minus the lowest value of the dependent variable, and you take this value divided by the range, you get the percentage. If the percentage is very large, then your standard error is large. That's how we determine whether the standard errors are large or small. Okay, so this is how you can calculate confidence interval if you need to calculate. I don't think so. We don't need to calculate this for your project. Okay. So that is the first test, whether the model is significant or not. Next is the test called individual variable. For individual variable, we are testing the beta value of the individual hypothesis, right? So the null hypothesis tells you there is no linear relationship. The alternative says there is a linear relationship. Okay, this is where you need to understand the difference between a non-directional hypothesis and a directional hypothesis. So this beta value can be greater than 0, can be smaller than 0. Greater than 0 means is positive. Smaller than 0 means it is negative relationship. Okay, that is how you understand negative and positive relationship. So how do they test whether these beta values are significant or not? This is a t value. T value equals to your beta value divided by standard error of the beta value, and it follows a degrees of freedom n minus k minus 1. Okay, n minus k minus 1. So we have these two values that will be given in the output. You have a column called the t value, right? The t value and the p value, they are inversely correlated. No? If the t value goes up, the p value will go down. Okay, so to interpret the t value, we need to first look at the table. Okay, we need to look at the table. So the table will give you a cutoff value of minus 2.1788 and plus 2.1788, and our calculated value is 2.306, which is here, and then the second variable also will be in the rejection region. So that is how we can do the test using the software, the calculation. Okay, but we can also look at the significance of the p value, right? Significance of the p value. Before we interpret the result, in most SPSS software, these p values are actually calculated based on a two-tail hypothesis. So if your hypothesis is a one-tail hypothesis, you need to divide this by 2. Okay, divide this by 2. 0.02 divided by 2, you get 0.02. 0.014 divided by 2, you get 0.007. 0.007. That you need to do manually. That you need to do manually. Yeah. So that is the values that we will interpret for individual variables, whether they are significant or not. Okay. So in multiple regression, we have 7 assumptions. The first assumption is called normality. The second assumption, this normality test, we cannot test using the software. We need to use a website called Web Power, so that we will not be able to do. Normality of the error term, we can test. Then we will look at the linearity, multi-collinearity, constant variance, outliers, and autocorrelation. Okay. So the first output you will get in a result is this called histogram. A histogram tests normality of the residuals or normality of the error term. This normality of the error term, we can look at the mean values and the standard deviation. If the mean value is close to 0 and standard deviation close to 1, then they are normally distributed. And you can see this normal distribution. Normal distribution. The second one is called normality of the error term. This one is given by the PP plot. As long as your scatter plot shows that the points are very close to the line, not perfectly on the line, very close to the line, then we can already assume the errors are normally distributed. Okay, these are two assumptions you need to test. Number 3 is linearity. Linearity is assessing whether your independent variable and dependent variable are positively correlated or negatively correlated. This is linear. Okay, this is linear. Positive linear, negative linear. This is curvilinear. Okay, all 3 curvilinear. The third one, no relationship. Okay, what we want to see is the positive linear relationship or negative linear relationship. That's number linearity. So since we have 2 independent variables, we can actually draw the line. This is between price and pie sales. The line will be negative. Okay, line will be negative. Then your advertisement and pie sale, the line will be positive. You can draw a straight line in between. So this is how you assess linearity in a multiple regression analysis. Okay, number 4 is called constant variance. Okay, constant variance is like this. This is your variance. Yeah, if your variance at this point is small, then it becomes larger at this point, or small here and becomes larger at this point. This is not constant. The variance is small here and then very large here. Okay. On the right hand side, we have variance large here, and then they become small. So this is the two what we call as heteroescadasity or non-constant variance. This is the one we are expecting to see in a multiple regression analysis. The variance remains the same, doesn't matter today, tomorrow, or day after tomorrow. This is called time. Okay. This is assumption number 4 called the constant variance. Okay. In your computer output, you can see result like this for the first variable and the second variable. This is for the pi sales, whether pi sales variance is constant or not constant. You can see that they are actually distributed above and below the zero. Okay. Number 5 is called the multicollinearity. For multicollinearity, this is a serious problem in multiple regression. This is when your dependent variables are highly correlated, or independent variables are highly correlated. Usually we will check the VIF, variance inflation factor. If the variance inflation factor is less than 5 or equal to 5, you are quite safe. But we can also look at a conditional index. If the conditional index is less than 30, you are very safe. More than 30, there might be suspicion of multicollinearity. Okay. The cutoff value in the literature, they have given 10, 5, 3.3, and 2.5. But currently, you should be looking at only 2. 5 or 3.3. Okay. 5 or 3.3. Those are the two numbers we will look at. Okay. So where do you get the value for collinearity? We will get it under the last column, which is called the VIF. As long as this is less than 5, you're okay. And then we will also look at the conditional index of collinearity diagnostic. They give you the conditional index here, 19.948, right? So you don't have a problem with multicollinearity. Okay. Number 6 is called outliers. Okay, outliers. For outliers, we can accept up to plus minus 3. Anything outside plus 3 or anything smaller than minus 3, they are called outliers. Okay, the software will be able to identify that for you. What we need to do is we need to remove that and see what happens to the result. If the result does not change, then you can conclude you don't have a problem. Leave the outliers as it is. We consider them to be non-influential. If you remove the data and it becomes significant, then you are saying the outliers are influential. That's how we design. We can run with and without and see what happens to the change. So how do you get that is in the software, they will give you, this is the context of outliers. All your points are near the line and they have one value very high, which is very far away from the line. At the top or at the bottom, right? This is called outliers. So when you run your analysis, they will give you this case-wise diagnostic. So when you run the analysis, you need to pick this assumption called case-wise diagnostic. They will run and give you this case. Which cases are considered as outliers? Why are these two case numbers considered outliers? Is because their standardized residual is more than plus 3. More than plus 3 or less than minus 3, they are considered outliers. So we can try removing these two cases and see what happens to the result. If the result does not change, we can leave the outliers saying that they are non-influential. And the last one that we will test for is called autocorrelation. Autocorrelation, we will look at a value called Darwin-Watson. And for Darwin-Watson, any value from 1.5 to 2.5, we can consider there is no problem. The best number is 2. The best number is 2. Any value 1.5 to 2.5 is okay. Anything more than 2.5, we have negative autocorrelation. Anything less than 1.5, we call them positive autocorrelation. This usually happens in time series. when the error term of time 1 is correlated with the error term of time 2. So in cross-sectional data, this should not be a problem. Should not be a problem. Okay. So those are the 7 assumptions you need to test. And for David Watson, they will give you this value called 1.683. Yeah. So what we already argued, anything between 1.5 and 2.5, they are okay. Yeah. They are okay. Yeah. So those are the 7 assumptions that is usually tested. Some of them are more serious. Some of them are less serious if they are violated. So you need to do that for your project. Yeah. Any questions on the assumption? Yes. Any questions on the assumption? Okay. No questions. Okay. So if no question, we will stop here for a break. We will take 30 minutes for the break. And then we will come back at 8 p.m. To discuss this regression with dummy variables. Okay. Regression with dummy variables. Okay. Okay, welcome back. Before the break, we were discussing about the multiple regression analysis with two independent variables. After you have run all the analysis, you need to summarize them into a table form. This is how you can present your result for a multiple regression analysis, like using the APA format. This last column, if you don't put also is fine. But the rest of the values like unstandardized beta, standard error, standardized beta, t value, p value, and the confidence interval, you should report as part of your hypothesis testing. Okay, as part of your hypothesis testing. So when you're writing in your results, this is the format that you can look at. This is APA format. You need to report the beta values, the t values, and the p value, okay? Whether they're significant at 5% or 1%. F value, you get degrees of freedom, k and n minus k minus 1, right? Okay. This is k, this is n minus k minus 1. So that's how you can report your result from a multiple regression analysis. This is provided you don't have any categorical variable. If you have a categorical variable, then let's say you have male, female, and then you have Malay, Chinese, Indian, others. You cannot enter these variables in your regression. This is where we need to create dummy variables. Dummy variables will have coded as 0 and 1 only. 0 and 1 only. So how do you know how many number of dummy variables needed is? If we have 3 groups, 3 minus 1, you need 2 dummy variables. If we have 4 groups, 4 minus 1, you need 3 dummy variables. That's how you create dummy variables in regression. For example, here we have gender as a dummy variable. Okay, gender, if you have 1 equals to male and 2 equals to female, let's say you want to regress gender against salary. When you run this analysis, you get an equation, salary equals to 1,000 plus 2,000 times gender. So if you put 1 as the gender, then your salary will be 1,000 times 1,000 plus 2,000 times 1 is 3,000. If you put the gender as 2, it will be 1,000 plus 2,000 times 2, 5,000. But it doesn't make sense, right? Gender is not an increasing, decreasing variable. Just because gender increased from 1 to 2 you get an increment of salary of 2,000. This does not make sense. So that is why we need to dummy code them into 0 and 1. So we will recode them into gender. 1 equals to male and 0 equals to female. So what happens to the equation is for the male, the whole equation applies. For the male, for the female, it stops here. This part here is 0. This part here is 0. So the benchmark is the 0 group. 0 group is a female group. Now we want to see the male group higher than or lower than. This is like doing a t-test in regression. So this is why we need to do dummy coding in regression if you plan to do categorical variables in your regression. Let's say now we want to regress pie sales against price and holiday. Holiday, we have 2 categories. One is if holiday, the other one is no holiday. Holiday period, the number of sales will go up, right? Okay. Non-holiday period, the number will be lower. So when we run the regression, we want to compare the holiday. When this holiday is the sales higher than non-holiday period. So this is where we are comparing the beta values. Okay. So if you get equation like this for holiday, 90 plus 1. So what you can conclude is during holiday period, you sell 90 pies more than a non-holiday period. Okay, 90 pies more on a holiday period as compared to a non-holiday period. So that is why we need to do a categorical variable. We need to dummy code them. Okay, you need to dummy code them. Okay, any questions on assessment of multiple regression and how to report? So reporting, I've already shown you. This is the report. Most of the analysis, I've already given you tables. And I've already shared with you earlier also. You can look at it, how to present the table. This is for multiple regression, which was not there earlier. Now we can look at the multiple regression. Okay. Next, we will look at an exercise I already shared with you. Hopefully, you have printed it out and look at the questions. Can you look at the questions? So this is okay. That's my view. Okay. This is the question that I asked you to print out. Okay. This is a typical multiple regression analysis output. And how do you use the multiple regression output for your answers? You need to look at these tables that is given to you. Okay. So what usually the question will give you is a description of the variables in your model. Here we have 3 independent variables, right? Subscription, population, and advertisement. The dependent variable is independent variables income, population, and advertisement. Your dependent variable is subscription. Okay, those are the 4 variables in the model, and they also give you some description of the data they have collected for subscription, for population, for advertisement and income, and the numbers are stated here. Okay, explanation. Then you will be given a result, which is the appendix as multiple regression. So the first table will give you a description of 3 independent variable, 1 dependent variable, and then you have your R square, just set R square, standard error, Derby Watson. This table will give you how good is the model. And then you have your F table, which gives you whether the overall model is significant or not. So we will look at this table. And then for individual variable, we have 3 of them. We will look at this coefficient table. And for multicollinearity, we will look at this collinearity diagnostic a bit later. And then they will give you several graphical output for assessment of the assumption. So these are the typical output that is given in a multiple regression analysis. So after you look at these values, these are the questions asked. Okay, these are the questions asked. Can you now take out your paper, pencil, and whatever you have? and start doing this so that we can see whether you have a good understanding of the interpretation. Okay. These are the questions that will be given. So the questions are actually answered based on the output already given earlier. So the first question will be develop the best fitting regression equation. Okay, like I already mentioned, when you are writing your regression equation, we already discussed this, right? Where do you get them from? Okay. Now look at the output and write the equation. This is an example we discussed with two independent variables. You have now three independent variables. Look at the table. This is the table that is needed to you need to look at. Quickly look at the output and write the regression equation. Okay. For writing an equation, we will look at the unstandardized coefficient, which comes from the coefficient table, the first column. So the constant is minus 5.733. The B value for population is 0.008 plus population. And then you have 0.051 times advertisement. And you have 1.097 times income. This is the column that we will use to write the equation. Okay. So hopefully by now you should understand how to write equation. This is the basic understanding and multiple regression. Where do you get the numbers to write a multiple regression equation? That's part A. Okay. Next we have how do you know whether the model is significant? Like I already mentioned, we have the ANOVA table, right? So the ANOVA table, you will get an F value and the P value, right? F value and the P value. If the P value is less than 0.05 is significant, more than 0.05 not significant. If it's significant, you are saying, I have a model that the three independent variable can explain my dependent variable. So this is the F value that we interpret. And the P value of this table is already significant. So we can conclude that all the three independent variables can significantly explain the dependent variable. Here we have the dependent variable is subscription, the independent variable is income, population, and advertisement. Okay, so that is how we answer questions to test whether you have a significant model. Okay. Then if you are given these numbers, first they give you a table that tells you what are the hypotheses you need to test. So they give you these three hypotheses. There is a positive relationship between population and subscription. When advertisement increases, the subscription will also increase. There is a positive relationship between income and subscription, right? So these are all stating the same thing, right? In different ways. All of them are moving in the same direction. So the null will be beta equals to 0. Alternate will be beta greater than 0 because these are all positive relationship. Positive relationship. You need to write these three hypotheses first before we look at the number. Okay. This hypothesis first before we look at the number. So after you have written the hypothesis, then only we can look at the result, which is given in this table, the t value and the p value. You can actually interpret the t value or the p value. They are inversely related. When the t value goes up, the p value goes down. Okay, t value goes up, p value goes down. And again, these p values given in SPSS, they are all based on two-tail. So if your hypothesis is like this, these are called one-tail or directional hypothesis. These p values, you need to divide by half before you interpret. Again, you divide the p value by half before you interpret. Okay, that's what you need to do. So these are the numbers given. So after we have written the hypothesis, we can actually summarize them here. This is the t value for the first variable called population. This is the p value. This is the alpha value we want to compare, which is given here, right? Alpha value is 1%. And then we decide on the rejection or hypothesis. If the p value is less than the alpha value, then you reject the null. If the p value is greater than the alpha value, you do not reject the H null. Okay, that's how the interpretation works. So 4.157 p value was 0. 3.599 p value is 0.02. It's actually 0.02. You need to divide by half. So it becomes 0.001. 0.000, you divide by half also is 0. Okay, so no point now. So this is the only one you need to divide by half. Then only your interpretation, which hypotheses are significant, which hypotheses are not significant. You can use T or the P. Okay, T or the P. Yeah. Any questions on the individual level hypothesis testing? Just now we were doing the construct, the model, whether the model is significant or not. We look at the F value. Now we are looking at individual variable. We have 3 independent variables. Whether all the independent variables are positively related or not, we already confirmed they are all positively related. Okay, they are all positively related. So that is how we test individual variable in a multiple regression, depending on the number of variables you have. Yeah, any questions on the interpretation of the significant, not significant? Okay, negative, it depends on your hypothesis. If your hypothesis says negative and it came out negative and it's significant, then it's supported. If you write negative relationship, came out positive, not supported. If you write positive and came out negative, also not supported. Sign must be similar. Okay, here, can you see here? This is positive, right? This is positive, this is positive. So if you look at the output, these values are all positive, right? All positive and they're all significant. That is why we reject the null, say alternate is true. If you write a positive and it comes out negative here, you cannot reject the null, because if you reject the null, you are saying the relationship is actually positive. And that is why we need to look at the sign first. Once it's significant, then only you look at the sign. If it's not significant, you conclude there is no relationship. Okay? Different. Okay. So that is how you test individual variables in a multiple regression. Okay. Next is, if you are given these numbers and you need to calculate the subscription. So you write the equation first with the variables in the bracket. Now what you need to do is you need to substitute these values into the equation. But when you substitute the values into the equation, you need to be careful. Okay, again here, if you see the table gives you description, right? Let me show you the description. The description tells you that, okay, this advertisement is in 100, income is in 1,000. Okay, advertisement is in 100, income is in 1,000. So the number 35.1 means 35,100. Okay, here 13.2 means 132. Okay, 132 times 100 times 100. So when you run this equation, when you substitute into the equation here, okay, you need to convert, okay? So this 13,500 become 13.5 because you times 100, right? Okay, and this one you divide by 100. This one, 34,700 is in thousands, right? So 34.7 you put in, okay? And that's how we get the number 37,814 Malaysian ringgit. You need to write Malaysian ringgit because the measurement of subscription is in Malaysian ringgit. Okay. Any questions on the substitution? Population is in thousands, right? That's why it's 599. Let me see the population. Okay, population, if you see the data here, okay, population is in thousands. So 588.9 means 588,900. But that's why they're writing in thousands. So here, when we substitute, you need to be careful in the equation. So we need to summarize them into this form. Okay, how do you check is when you get the calculated value here, we can go back and check the dependent variable. Okay. If you see here, these are 37,000. Okay, subscription is in thousands, right? So 379, 37, you times with 1,000. Okay, this one you times with 1,000. So if the values are like 37,950, still okay, right? But you get 70,000, 80,000. They are not in the range. They are not in the range, which is not possible. When you do regression analysis, your dependent variables calculated based on these values, right? So they cannot be anything bigger than or very much lower than this number. So that's how you calculate your dependent variable given x1, x2, and x3. Okay, and that's calculation. Okay. And then we have the R square, which is given here, right? The R square measures the total variation that is explained by the three independent variables. So the three independent variables can explain 83.5% of the variance in subscription. Okay, 83.5%. We have another 16.5% variation that cannot be explained by this regression model because we have other variables that we have not included in the model. That is why we don't get 100%. And there's no way you can get 100% unless you have 20 variables in the model. So 83.5% is already pretty high for any regression analysis. So that's how we interpret the R square. If you get 20%, you should be worried because usually you don't get that kind of numbers with this independent variable. Should be higher. Should be higher. That is how you answer the calculation. Okay. And then we have this assumption. For assumption, we have 7 of them. Assumption number 1, we cannot test using SPSS because we need to use a web power multivariate kurtosis. This one, I already taught you how to do. Upload your data to this web page called Web Power. It will tell you whether you have univariate normality and multivariate normality. That's number 1. Number 2 and number 2, these two, we will assess whether the errors are normally distributed. We will look at the histogram, and then we will look at the PP plot. Number 3, which is partial plot, we will look at the linearity. This is testing linearity. We will look at the partial plot. Multicollinearity, we will look at the VIF. It's not less than 10. It should be 5. Can you change this? It should be 5. Less than 5, not 10. Okay, constant variance, we will look at the studentized residual against the dependent variable, depending on your question. And then we will look at the outlier. Okay, outliers, we will look at the case-wise diagnostic. If not, we can also look at the histogram to see. Finally, we look at the autocorrelation by looking at the Darwin-Watson value, right? Darwin-Watson value, whether it's between 1.5 and 2.5. So for the histogram and the normal probability plot, you will see most of the points are very close to the line. and the histogram looks very normal, okay, with one peak. Okay, mean is close to 0, standard deviation is close to 1. Okay, so that's already confirms we have normality of the error. This is assumption number 2. Yeah, assumption number 3 is linearity. We have 3 independent variables, and they are all positive, right? So can we draw a straight line in between? Yes, we can draw one line here, and we can draw one line here. So that is what is meant by linearity. Do the 2 variables move in the same direction? And they are linear. Okay, that's number 3. Okay, number 4, we will assess multicollinearity by looking at the VIF. And if you see here, the VIF are all less than 5, right? Okay, that already tells you you don't have any problem with multicollinearity. Okay, multicollinearity. Number 5 is constant variance. This is the plot we added just now, studentized residual against dependent variable or predicted dependent variable. As long as you don't see any pattern of increasing values or decreasing variance, then you're okay. Here we have a 0, some are above, some are below. We don't see high and then become low, or from small become large, then you're okay. This is assumption number 5, which is called constant variance. Okay, assumption number 6 is called outliers. Sometimes you don't get a table, which is called a case-wise diagnostic. Then you can look at the histogram. If you see here, we have plus minus 2 only, right? Standardized residual. Outliers are plus minus 3. Outside plus minus 3. So that is why you don't see any case-wise diagnostic if you have this kind of distribution. If you have a 4, if you have a 5, here 4, minus 4 or 5, then only you will see outliers. Okay, here they are within plus minus 2. That is why you don't get a value for the case-wise diagnostic. Okay. And assumption number 7 is called the autocorrelation. Autocorrelation, the value should be within 1.5 and 2.5. And if you see the number here is 2.279. So we can already conclude we don't have a problem with autocorrelation. So that is how the 7 assumption can be assessed. And finally, after you run the analysis, you need to write an implication, an implication section. The implication section will follow the beta values, the standardized beta values. The standardized beta values will tell you which variable is more important or less important in predicting your dependent variable. So based on this, you need to write how can you strategize. Okay, here we have an example. So if they want to increase the subscription, then they have to target populated cities which has higher income. These are the 2 predictors, the main predictors of your subscription, right? So that is how you leverage on the findings to write your discussion later. Okay, you already have your regression. From your regression, what can you suggest to the company? Okay, yeah. Any question on the testing and analyzing multiple regression analysis? Okay, very quiet now. Okay, so when you run your regression analysis, I will show you how to run your bootstrapping, just in case anybody has a problem with non-normality. We need to run a procedure called bootstrapping. Okay, so we will run analyze regression, linear regression. The dependent variable in the paper that I shared earlier, the data I shared earlier, these are the 3 variables. Okay. So we have 1 dependent variable, 3 independent variable. The first thing we will set is under the statistics. Okay. We need to estimate confidence interval 90%. We need the descriptive, we need the collinearity, we need the Darwin-Watson and case-wise diagnostic. Okay. These are the things you need to click for under statistics. Huh? Okay. Next is after we click continue, under the plot, okay, we will need the histogram, the normal probability plot, produce partial plot, and an additional thing you need to do is studentized residual, and we can take the dependent or the standardized predictor, which one also can. So this is the assumption, the 7 assumption. Then you click continue. Okay. Let's say you have data which is not multivariate normal. Then you need to click this button called bootstrapping. Okay, bootstrapping. And you click this number bootstrapping. And we need to set this machine twister. Change this to 90%. Okay. These are the things you need to do if your data is not multivariate normal. Sharmila, you asked that question, right? If your data is not multivariate normal, you need to invoke this procedure called bootstrapping. Okay. This one we can run 10,000 actually by right supposed to run 10,000, but it takes a long time. So I will not run so long. Okay, so we will run this. Confidence interval is 90%, percentile bootstrapping. We click continue, and then only we click OK. But this will take a bit of time because they are running 1,000 times bootstrapping, right? You see at the bottom here, they are running multiple regression with bootstrapping. So it takes a bit of time. Some PC, it will stop running. So that's why I didn't run 10,000. Okay, hopefully you get these results. Okay, so here you can see some case-wise diagnostic. These numbers you need to remove, right? I already mentioned. And you can see here we have this bootstrapping. Okay, for those who have non-normal data, non-multivariate normal data, you will need to report your beta values from here, same value, right? These are same values, right? Can you see? The values are the same, but you need to report the standard error from here, not here. Okay, here, not here. Okay, p-value you report from here. Confidence interval you report from here. Okay, so this table is the one you will use for reporting your result if your data is not multivariate normal. Again, I repeat now. If you want to report the standardized beta, you can copy from here. Doesn't matter. The unstandardized beta you take from here. Standard error you take from here. P-value you take from here. Confidence interval you take from this table. Because when your data is not multivariate normal, we need to correct the standard errors. That is what we are doing in this study. Okay, here, this part. Okay. And how to remove the outliers, I've already shown in earlier classes, right? Okay, outliers is something like this. So if you want to remove this case number 70, you go under data, select cases. Okay, data, select cases. Okay, and what you do is you want to remove if condition, right? This if condition, click this if condition, pull this a bit so that you can see. Okay, we want to remove case number 70, 82, 83, 166, 178, and 179. What you do is you click here, and we have this button called not equals to. Not equals to. Click this, and the first number is 70, space, and then N, and you bring in ID again. Not equals to, the next number is 82. So you can copy and paste. I think you are very good at copy pasting, right? Can copy and paste this. copy this and paste, and we can change the number to 83. We change the number to 166, 178, and 179. Okay. So what we are telling the system to do is we are asking the system to temporarily deselect these 6 cases. Deselect these 6 cases. So once you click continue and then OK, what will happen is your data set, if you go to your data set, see these cases 70, 82, 83, 166, 178, 179 will not be selected. If you see here, they have a 0 and 1. Okay, that tells you that a 0 will not be selected. Only 1 will be used in the analysis. This is called filtering. This is called filtering. So now when you run the analysis, your result will change. Your result will change. So these are for outliers. Okay. Yeah. Okay. Any questions on these 2 issues? Outliers and bootstrapping. So, yes. Any questions? Okay. Still no question. Okay. Now, if you look at your teaching plan, if you look at the teaching plan, your teaching plan clearly already stated your final exam will cover which course learning outcome. Okay. These are the 4 questions you will have in your final exam, which will cover course learning outcome number 1 and course learning outcome number 3. Okay. What is number 1 and number 3? They actually covered here. So if you look at your teaching plan, these are already covered in your test. So they will not be asked in the final exam. So this one, probability sampling, this basic probability, discrete probability, continuous probability, they will be covered in the final exam. Can you see here clearly stated? Final exam, final exam, final exam, final exam, final exam, everything is final exam, right? So these are the topics that will be covered in the final exams, not the earlier topics. These topics will not be covered. These are already done. Okay. So we have this week number 6. Okay, we have this number 6, right? Okay, this is week number 6. So later when I say which topic is week 6, this is the topic. Week 7, this is the topic. So you should know by this topic. If I state chapter also, you are very confused people, right? So we will look at this week. Okay. So these are the topics that will be covered in the final exam. So you will have 4 questions, right? Question number 1, question number 2, question number 3, and number 4. Each will have subsection. Maybe part 1, part 2. Under question number 1, you may have 2 or 3 questions, sub-questions. Under question number 2, you'll have 2 or 3 sub-questions. So that is what you need to remember. Okay, so here in question number 1, you will get questions about week number 6 and 7, which is basic probability and discrete probability. Okay, this one. Week number 6 and 7. Basic probability and discrete probability. Question number 2 will ask 2 questions, at least, which were 2 chapters, which is week number 13, chi-square analysis, and week number 14, which is your multiple regression analysis. These 2 chapters will be in this question. This is week number 6, week number 7. This is week number 13, week number 14. Okay. Question number 3 will cover week number 11 and week number 12. Week number 11 was 1 sample test. Week number 12 is two sample tests, two and more than two sample tests, right? So this will be question number 3. And then question number 4 will be covering chapter number 9 and number 10. Week number 9 and number 10. Week number 9 is normal distribution, and week number 10 is sampling distribution. So those are the topics. 6, 7, week number 6, week number 7, week number 9, number 10, number 11, number 12, number 13, and number 14. Those are the topics that will be covered in the final exam question. Okay. And the kind of question you can already look at the past year question. I've already covered. One way ANOVA, you will not be doing. One way ANOVA. Okay. One way ANOVA. Okay. One way ANOVA is for the analysis only, not covered in the final exam. Okay. Chapter number 12 is not covered in the final exam, is covered in the chapter number 12, the two sample test is covered. The ANOVA is not covered in the final exam. One way ANOVA. Okay. Idris. Okay. 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 So look at the past year questions. You have 2 hours to complete your exam. So God bless you. For those who have not tried on paper and pencil, it's high time you do that before the 15th of July. Your final exam is on the 15th of July, 9 to 11. Okay, 9 to 11. We have 2 modes. One is for the ODL, and the other one is face-to-face. Okay, face-to-face, you have to answer all in the exam script. If you don't answer anything, you get zeros. Okay. If you at least attempt, you get some marks. Okay. That's what I can remind you. And for those who are living in outer space, I've already provided you with all these very much earlier. All the tables are provided, and still people are asking me, will you give me the formulas? Formulas are already provided upfront. Okay. These are the formulas already given to you. So you need to familiarize with them. And the formulas, the tables are also already given to you, right? All these I've already distributed. The only problem was one of the F table was not working very well. I've already updated. So it should work. All of these tables are already given. For those who are ODL, you can use them. For those who are face-to-face, all these will be provided in the appendix. Okay, you need to use them only. Okay, no need to bring anything to the exam hall. For the exam, you only bring your pen, pencil, ruler, and calculator. Okay, and calculator. Okay, if you don't bring calculator, then God bless you lah. Nobody will provide you with a calculator. Okay, this is a calculation course, right? You come prepared with a calculator. Okay. Yeah, those are the things you need to be prepared. Yeah, any other questions you have? It's all on the e-learn. Idris, is this your first semester? Okay. Is this your first semester answering? I don't think so, right? Highlighter you can bring. Highlighter is part of your stationery, right? Okay. Okay, Muhammad. Okay. So we have 2 Muhammads here. We have, for those who are ODL, you need to upload in the ODL. Okay, if you want lockdown browser, we can do for you, like Clifford. Special for you. You need to write. You need to write, then you want to take photo and upload also, you can. Any other questions? Yes, yes. Elan, Elan. You can type. I don't think so. You have enough time to type, lah. Okay. It is better for you to write, Okay, I already repeated 10 times, Jiang, From week one, we already talked about this. Formula already given to you. Question number 4 is week 9 and 10. Week 9 and 10, which is 1 sample and 2 sample. Okay, no. Sampling distribution. Sampling distribution, right? Chapter 9, week 9 is normal distribution and sampling distribution. Okay. Your project and assignment you need to submit by, you already know the date, right? I cannot get into Elan. Elan is still down, so if you cannot mark your attendance, I will do it manually. Yeah, any other questions you have about the project submission or the final exam? Before we stop for today. You already have 3 past year questions. Okay. Please try them out. Okay. Project question I have went through many times already, Muhammad. Okay. I already have, there's also lecture that was done on which question looks at one. You don't need a webcam, Albert. E-learning, exam will be on e-learning, right? Okay. ODL will be on ODL. ODL. Yeah. The ODL one will be on the ODL platform, right? Okay. For the online one, they have extra time for uploading. I think maybe 15 minutes, right, Doctor? Yeah, 15 minutes. Nobody has a question? Okay, if you have done your work well, then it should be okay lah. You already have 3 past year question, Idris. Nobody gives you that kind of question, right? Any other courses you get that? You don't, right? Okay. Please go and try that. You have only 2 hours, so you need to try them out whether you can finish in 2 hours. Usually students complain they don't have enough time because they spend too much time on the easier question. Okay. Okay, for those who have still have problems in their project and assignment, you have now until the date for submission. The deadline is a hard deadline. If you don't submit during that date, you are dead. Okay, that I can tell you for sure. If you have any question you want to ask, you can always connect through the internet, Zoom or WebEx. Okay, you can set up a time to discuss. And we can arrange anytime, okay, when I'm free. So you have to email me the date and the time, then we can do a discussion. If you don't want, then it's up to you. Those are the things you have to do. Thank you very much for the cooperation you have given the last 13 weeks. If I have said something to offend you, please don't take it to heart. I'm a very passionate person, so that's why I'm concerned. Okay. So good luck. Hopefully, I don't see you again next year. Okay. Till we meet in another course. Thank you very much. Take care and all the best.